everyone. We are going to start in chapter 7 this week, which is systems of equations and matrices. This is on page 42 in your note guide, and we will also continue with the review assignment. So we're going to do 7.1, 7.2, 7.3, and we're going to end up doing review number 4 and review number 5 this week. So looking at a system of equations, if they're linear, it means you have two or more equations. When we look at the solution, which is an ordered pair, x, y, this ordered pair is going to make both equations true. So when you plug in x and y, you will make both of those equations balance out and be true. So let's think of some special cases. Special cases would be if we have no solution. What that looks like is you have parallel lines that do not intersect, so they don't have a solution in common. So this is called inconsistent. Inconsistent as well as independent for no solutions. Now, infinite solutions means you have coincident lines. This is what this looks like. So you have lines that are basically on top of each other. So everything that's true for one line is true for the other line. Then we also have exactly one solution where we get lines that intersect in exactly one place. So looking at example 1, we're going to graph both lines on the same graph, and then the point of intersection is the solution to the system. So the first line I have is 3x plus y equals 4. I subtracted the 3x and changed it to slope-intercept form. I was just getting ready to graph it. So plus 4 means I start at 4 on the y-axis. I'm going to drop down 3, 1, 2, 3, and to the right 1. And down 1, 2, 3, to the right 1. And it's hard to graph on this and make your line really straight, but I can sure try. So there's my line. And then what we're going to do is graph the x subtract 2y equals 6, and I did that in purple. This time I graphed a different way. I graphed by x and y intercepts. Just a reminder on how you do that is you plug in 0 for y, so that gives me just x equals 6. That means that I have a point here at x equals 6. So right 6 and up 0. Then I plugged in 0 for x, and I got y equals -3. That gives me the y-intercept of 0, -3, which is here. And then you connect your intercepts, and so I'm going to connect those two. And if your graph isn't really accurate, then it's difficult to come up with the solution, where algebraically you can just come up with it. But we're looking for where these two graphs intersect, and that's going to be at 2, -2. So that's your solution. In example 2, we're going to solve a system that is not completely linear. So the first line, we had 3x plus 2y equals 6. I went ahead and graphed that by intercept. So I plugged in a 0 for y and got x equals 2, graphed it here. Plugged in a 0 for x and got y equals 3, graphed it here, and graphed my line. Now the second equation happens to be logarithmic. So y equals ln x minus 1. And so let me do green, color coordinate here, right? So what we're going to do is the natural logarithm graph, the parent graph goes through 1, 0. So it looks something like this. But we're going to shift that graph to the right, opposite of what you think, right one. So I'm going to take that logarithmic graph. I'm going to move it to the right 1 unit. Oh, I can see where my intersection is going to be. And here is my graph. So what is the solution to the system? That's going to be where I have this intersection, which is right 2 and up 0. So solution to the system is 2, 0. We always write it as an ordered pair. Example 3 is I'm going to solve the system of linear equations by substitution. What I like to do is put one equation on the left side and one equation on the right side. Then in the first column, which has the negative 3x plus y equals 7, I am going to solve for a variable. And it doesn't matter which variable you solve for, so always just pick the easiest variable. In this case, it's y. So y equals 3x plus 7. Now, if this is an Arborview football game, over here, y, I like to circle it, is the quarterback. And I come over here, here's y, our quarterback. And out is going to go y, and in is going to go the quarterback sub, which is a different guy in the same position, quarterback. So 3x plus 7. So over here we have negative 6x plus 2, and in is going to come my sub, 3x plus 7. I was trying to put my sub in a different color. 3x plus 7. And equals negative 8. And you're always going to have everything in one variable now. So we'll simplify negative 6x plus, and then make sure you distribute the 2, 6x plus 14 is equal to negative 8. Now this is going to be a strange solution because the x's just completely canceled. And if everything cancels, but this is definitely not true. If it were true, like 14 equals 14, it would be infinite solutions. But because it's not true, the answer to this problem is no, spelled that wrong. Erase, 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 erase. All right, back to the word solutions. No solutions. Ta-da! And maybe just no solution. I don't even need that S there. Next, we're going to solve a system that is nonlinear by substitution. You can see that I put one equation in each column again. So in the left column, I have the y equals x squared subtract 1, which is a parabola. And in the right column, I have a circle, x squared plus y squared equals 13. Now, because this is nonlinear, it is easier to solve for x squared than it is to use y equals. Because if you were to plug x squared minus 1 in for y, you would have to square that, and now you have a pretty complicated equation. So what I'm going to do instead is solve for x squared. X squared is equal to y plus 1. And now, just like I did before, x squared is going to go out, and in is going to go its sub, which is y plus 1 plus y squared equals 13. You can see I have a quadratic equation, so I'm going to set the whole thing equal to 0. Subtracting the 13 to the left is y squared plus y subtract 12 equals 0. And then I will factor just like I do a regular quadratic equation. And I have 4 and 3. And the 4 is going to be positive and the 3 is going to be negative. So now y plus 4 is equal to 0, and y subtract 3 is equal to 0. 0 product property, and y is equal to negative 4. Here you're going to add the 3, and y is equal to 3. So now what I'm going to do is come over here and substitute in my solution. So I'm going to put in negative 4 for y. X squared equals negative 4 plus 1. X squared equals negative 3. When I square root both sides, this is a problem because there's a negative under a radical. So that part is no solution. So the negative 4 is no good. Let's try the other one. So I have x squared equals, I'm going to plug in a 3 for y, plus 1. This is going to turn out beautifully. When I square root, don't forget the plus or minus, x is equal to plus or minus 2. So this means I get the solution when x is 2, y is 3, and when x is negative 2, y is also 3. And I'm going to quickly draw the picture. So here's this adorably cute picture down here for you. And you can see that you have a circle and a parabola, and here's where they intersect at right 2 up 3 and left 2 up 3. Example 5 and example 6, I'm going to let you try on your own. They are in your book, which you can look up under your homework assignment. And if you will go to page 476 and use example 2 to walk you through example 5. And on example 6, if you will go to page 479 and look up example 6. If you'll try both of those problems, then when we meet in our Google Meet, I'm happy to do them for those of you who need help on them. Thanks, you guys. Have a fabulous day.